Hi and welcome to another very exciting tutorial. Today we're going to build this cool 3D game that uses a game world that we actually created in the last SceneKit tutorial. We're going to use motion data now to control the ball you're seeing, and we're going to create an amazing follow camera that follows our ball very smoothly wherever it goes. And we're also going to talk about bit masks and collisions and so much more. So go ahead and download the start files from the video description below. Be sure to subscribe to this channel to not miss any new tutorials while you're at it, and then let's get started. So once you've downloaded the start files, you can just open up the Xcode Project, hit the tree, and what you will find there is an already existing game world that we built in the last tutorial. So we already built these trees from scratch. We built the ball, we created the skybox and the complete environment that you see here. So this is already added to this project. What we also have are two helper classes here. One that is going to support us in getting data from the accelerometer. This is nothing fancy, you'll understand it right away, but I'd like to focus on implementing the game logic at itself and not focusing on creating or discussing the accelerometer. And what I've also added are just a few simple vector operations for adding two vectors. We're in 3D space, so we have to operate with vectors and do some vector calculations. And this is just going to simplify the way we can add two vectors. We also have a sounds folder here, our sound group, with some nice background music, some sounds for the chainsaw once we hit one of the trees, and also a nice little jump sound. And this is all there is to it. So we have these helpers, we have some sounds, we have a ball, we have a tree, and we have our main game scene that combines all of that together. So to get started, let's open up the game view controller Swift file. And what we already did there in the last tutorial is just add some code so that we can display our scene. And this is what we do in the function setup scene. So since we have our main storyboard here, it does not contain a standard UI view. It contains a SceneKit view, so an SCN view. And we're just going to cast that view that we get from our view controller as an SCN view. And then we can do some stuff like allow camera control so that we can move around and just have a detailed look even without having to write some code about cameras. We're going to remove that later. And then we're loading the scene that we have created in our main scene.scn file and just put that in our scene views scene property. Then we have a should auto rotate property here that we set to false, and we want our status bar to be hidden, and nothing else is here at the moment. So we're going to start by adding all of the properties that we're going to need to make this game happen. And there are just a few of them that are going to connect our nodes that we have already created in our main scene, and we're going to connect that to our code right now by adding some properties like a ball node, which is an SCN node. So this is going to connect our ball to the code later. And what we're also going to have is quite a fancy name, actually. It's a selfie stick node, also an SCN node. And this is going to help us control the camera and not having to accommodate for the spinning of our ball once we're following it through the scene, because we want to implement a nice follow camera. Then what we also need is some properties for the motion control. First of all, I'm going to add a motion property here, which is an instance of our motion helper in the helper class section. And then we're also going to add a motion force property that is a vector, since a force has a direction and a strength. So we're needing a vector to map this this motion force, and we're going to initialize that with an x, y, and z value, and we're just zeroing that out for now. And the last property that we're going to need for now is a sounds property, which I decided to be a dictionary with a string for the keys and SCN audio nodes audio sources as the values so that we can simply access our sound files and the preloaded sounds when we need them. And then I'm also going to initialize that right here with an empty dictionary. And with that, we almost have all the properties that we need, and we can set up our next function that we're going to need, which is going to be set up the nodes. So right below the function setup scene, I'm going to add a function setup nodes, and I'm also going to call that right in view.load. So call setup nodes right here. And in setup nodes, we really want to connect our ball and our selfie stick with the properties that we have created in our game view controller. So to do that, we're accessing the property, for example, ball node, and then we're accessing our scene. So we have our scene, and our scene has a root node. This is the root node of our scene graph. And then we can just use child nodes with name. This is a very cool function because it allows us to search for a child node by its name, and we should make sure that our ball has the name ball, and we'll set recursively to true, and we can also directly unwrap this because we're going to make sure right away that our child node indeed has the name ball. So we're having a look at our ball.scn file, and as you can see, our ball indeed has the name ball. We can also have a look at that in the node inspector. Again, there is the identity, it is ball. And once we have a look at our main scene, because we're coming from the main scene, you can see that there is the ball reference, and in this ball reference we have our ball. And since we set recursively to true, we can move all the way down through the tree and look for the child node with the name ball, and by that, getting that right away. And we've already talked about the next node that we actually need to set up, which is our selfie stick node, but we cannot connect that from our main scene yet because we still need to connect or to create our selfie stick. And therefore, what I'd like to do is adding a child node to my scene graph, and I can do that with the plus button in the lower left corner. This just adds an untitled child node, and in the node inspector I'm just giving it the name selfie stick, and we already positioned that at 0, 0, 0. And what I'd like to do is change the X angle to -30 so that we kind of look downwards at our scene. And now the most important step for this selfie stick to work is putting our camera into our selfie stick. So making it a child node of it. And I'm just dragging and dropping my camera into my selfie stick. And then what I'd also like to do is take the perspective of our camera. So in the bottom bar, I'm just selecting perspective, and then I can select camera, which is currently outside of my recording area. And then I can make some adjustments here. So our camera or our selfie stick is currently positioned at 0, 0, 0 with an angle or an X angle of -30 degrees. So this is good. Now I'm also changing the camera, and I'd like to zero out the Y coordinate, but I'd like to position it 5 steps in Z direction. But what I'd also like to do is just zero out the angles here as well, which gives me this perspective from the camera. And when we change back to our perspective mode, then you can see that we have the camera currently in the top right corner. And let's just imagine that our selfie stick originates from this point, which means you kind of hold that in your hand, and this is the length of the selfie stick, and then the camera always points at us, and we can just drag along our stick once we move the ball. So a very cool technique that we can use here, and now we just have to connect that with our node property in the game view controller. So in setup nodes, I'm now taking my selfie stick node, I'm using my scene, and the root node, the child node with name, we called it selfie stick, and we again use recursively true and directly unwrap this because we can be sure that we named that correctly. And since we're currently dealing with the setup process, let's also do the sound setup right away. So let's add a new function. Let's call it setup sounds. And this is really straightforward. We're going to load all of the sound files that we need, adjust the volume, and prepare it for usage in the later progress of our tutorial. So let's maybe start with the saw sound. This is just using an SCN audio source. And we can just initialize that with a file name using the file named initializer. And the first one is the chain saw.wav. And we also have the jump sound SCN audio source, file named. This is jump. And the file extension. Then what we do is load the saw sound, and we can actually also unwrap that right away because I'm pretty sure that I named them correctly. And then we can use the saw sound and load it. We can use the jump sound and also load it. We can then use the saw sound, adjust the volume a little bit. I figured out that 0.3 is a good volume for the saw sound, and for the jump sound, I'm using a volume of 0.4, so 40%. And then what we can do is put these objects, these audio sources, into our sounds dictionary for a specific key. So I'm using, first of all, the saw key, and then I assign the saw sound. I'm using, again, my sounds dictionary, using the jump key, and assigning the jump sound, and then this is already prepared. But now we also have a background music, therefore I'm going to create a background music object. This is also an SCN audio source with a file named, in this case it's background.mp3. And this is all in our sounds folder here. And then what I'd like to do here as well is adjusting this a little bit, unwrapping it first. So background music and the volume, let's set this to 10%. Then what I also want to adjust is looping this background music so that it reoccurs every time the actual file ended or the duration of our file, our music file completed. And then what I'd also like to do is just load this background music. And then to play it, what I need to do is create a music player. This is an SCN audio player. And I initialize that with an SCN audio source. So there we use our background music. And then all we need to do is adding this music player to a node. I think our ball node is a good choice here. So I just say add audio player here, and then I add my music player. And that's all there is to setting up our sounds. Let's just call that InView.load. And then all the setup functions are complete in its basic form. We're going to return to do some adjustments later, but for now, this is cool. The next step that we're going to take is add the first functionality to our game, because if you remember, when you tap the ball, then you make it kind of jump, and we want to implement that right now using a gesture recognizer. So below my setup sound functions, I'm going to add a new function. I'm going to call that SceneViewTapped, and this is going to receive one parameter, which is the recognizer. And recognizer, and this is UI tab gesture recognizer. And in this function, we're going to have a look at where the user tapped and check if our ball was actually tapped, and therefore we're using some simple hit test methods. So first of all, let's get the location of our tap. So we're using the recognizer for that, and just the location in our scene view. And with that result, we can then check or create a hit results object. I'm also going to call that hit results using our scene view and performing a simple hit test with a point. And therefore, we're using our location, which is a CG point, and we do not need any options here. So if we have now our hit results, or if we do have a hit result, then we can check this with using hit results and then count that. And if we have more than 0 hit results, we can just continue. And we're interested now in the first result in this hit results array. So I'm creating a result object here using my hit results and accessing the first object. And now the interesting part is that we can now check what kind of node this is. So I'm creating an if-let statement here using a node object. So using my results and this, or using my one result and accessing the node that intersected with our search beam or with the search ray when we performed the hit test. And then when we get such a node, and if this is successful and we indeed have an unwrapped node object, then we can check if this node and its name is equal to ball. And if that is the case, if we indeed have hit a ball object, then we get our jump sound to perform a little jumpy sound, actually. We can do that by accessing our sounds dictionary and using the jump key, and we can wrap this. And then what we'd like to do is perform 2 actions. First of all, we want to play our sound, and then we also want to apply some physics. We want to apply a force as an impulse that lets this ball jump a little bit. So we're using our ball node first, and we run an action to perform or to run our sound. So I'm calling the run action function, and we can play a sound using an SCN action. They're pretty similar to the SK actions that you might know from SpriteKit. So using an SCN action, we can then use play audio. We have an audio source. This is our jump sound, and we do not want for this sound to complete. And with that, we run a sound every time, or we run this jump sound every time we hit our ball. And then to perform or to apply some physics, all we need to do is use our ball node, its physics body. This is the body that we actually still need to create. But let's maybe first of all apply this force as an impulse. And therefore, we need to specify a direction using our, using a vector, so an SCN vector 3 with 3 components, an X component. We do not want to move it in X direction, but we want to move it in Y direction, let's say 4, and we want to move it in Z direction and in negative Z direction in that case, so that we actually fly towards the tree. So I just selected -2 as a good value here, but you can choose whatever you like here. And then I just want to make sure that this is an impulse, so we just apply this force once, and then there is no constant force applied to our ball. But at the moment, we cannot apply a force to our ball because it has not yet such a physics body. So let's change that. Let's move to the ball and select it, and then there is this show the physics inspector button in our right area here. And at the moment, this ball does not have any kind of physics body. And we can now choose how our ball should actually perform. Should it perform static or dynamic or kinematic? And we're interested in a dynamic behavior because we actually want every kind of physics actually being applied to our ball. And this also means that there's gravity, there's resting, there's friction, the ball has a mass, there is damping, and so on. And we just want to keep all of these settings as they are. What we'd like to adjust is to adjust the physics shape. I'd like to have a sphere here. And that's all the changes we need here. And then there is this section for bit masks. And there are 3 kinds of bit masks: category mask, collision mask, and contact mask. And these are actually responsible for dealing with collisions. And they're going to help us decide which objects can actually collide with one another and which objects also trigger events in the case that something got hit. We are especially interested in a hit event when our ball hits a tree, but we're not interested every time our ball runs around the grass. So what we need to do is a little setup for these category, collision, and contact masks. And they're called bit masks because we're actually using bits to set them, but we can also use integer values. I'm going to show you how to do that in a second. So we're starting with the category bit mask, which identifies each object that we can use. And we're dealing with bits, so we have 8 bits every time we can set such a category or collision or contact mask. And they're, of course, also associated with an integer value. So we have, if you take all of these values here, these 8 values, we're starting to count these bits at 0, and we have, of course, 8 bits that form a byte, and we have these values here that are actually creating a number in the binary system. We want to work in the decimal system, so let's just do that. So let me show you how this works. We have air. We do not need a category bit mask for air, so we're setting this to 0. But let's say we activate the first bit of our category bit mask for the ball. This would give us a decimal value of 1. If we set the second bit for our tree, then we get a decimal value of 2. So this would be the binary value 000000010. This is 2 in the decimal system. And we can just move along here to actually assign category bit masks for more and more objects or more and more nodes that we have. So these are the 3 values that we're going to use for the ball, for the tree, and for the grass or for our ground. And now, how does this work in relation to the collisions? Let me scroll a little bit to the right here, and here I have some collision masks. So when we want our ball to actually collide with the grass and also with the trees, then if we move to the left again, you can see that we have activated the second and the third bit for tree and grass. This is the green and the yellow box. So let's move to the right again. And as you can see, for the collision mask of our ball, we also set the third and second bit. And in the decimal system, this converts to 6 because 4 plus 2 equals 6. And we want our tree and our grass to collide with the ball, so we set these collision masks to 1. And we're going to have a look at the contact bit mask in a later part of this video. But now let's actually have a look at the values again. So the ball should get a value of 1, the tree a value of 2, and grass a value of 4. So let's just assign these values here and move along to the collision bit mask in a second. So the ball already has a category mask of 1. Let's open up the tree. And here I'm also going to select a physics body. But this tree should not be allowed to actually move around or anything, so we can go with a static behavior here, and we can still adjust the bit masks here. And as you can see, at the moment, we have a category bit mask of 2 right here, and this is already fine. And let's now move to the main scene and select the floor and see what kind of a category bit mask we get here. Also, the floor is also static, and here we have a category mask of 2, and we actually want to change that to 4. And then, if we're having a look at the collision masks, we can just start with the grass here or with the floor. We want the floor to actually collide with our ball, so I set this to 1. Then let's move to the tree. We also want our tree to collide with the ball, so I also set the collision mask of the tree to 1. And let's now move to the ball. We actually want the ball to collide with the trees and the grass or with the ground or floor, so we need to set this collision mask to 6, as I've showed you in this table. And if you are new to these bit masks, then just move along and create such a table for you every time you need to adjust the bit masks for some of your nodes or for many of your nodes. Actually, I'm sure that this is going to be a great help here. So with these settings applied, we can now move back to our game view controller. We have physics bodies now for our ball. We have a physics body for our tree and for the ground. Now all we need to do is still add our gesture recognizer. And for this to work, we need to add a little Objective-C indicator here in front of our function so that we can actually call this selector from our action parameter list in the setup scene function. So what I'd like to do here is first of all create a tab recognizer, which is a UI tab gesture recognizer. Then I can adjust that. Let's say the tab recognizer should require a tab amount of 1, and we also just need a single touch, so number of touches required is also 1. And then we can add our function to this recognizer, and this is why we needed to add this Objective-C flag. So I'm using tab gesture recognizer add target. This is self, of course. This is our current game view controller class. But now I have to use hashtag selector, and then I can use an Objective-C method here using game view controller and scene view tab or scene view tabbed with a recognizer. And with that in place, we have connected our scene view tabbed function with the tab gesture recognizer, and we can now use our scene view and add this gesture recognizer to it. So just add the tab recognizer, and now we can run our game for the first time in the simulator. And if everything went as planned, we should hear some music, and we do indeed. Just turning down the volume a little bit. And we should also perform a jump. I can click here anywhere on the screen, but I can also click on the ball, and now I have triggered a nice jump. And as you can see, our ball moves and moves and moves and also reaches the ground. Again, it does not fall through the grass, it bounces off it, so everything went as planned. So let me just close down the simulator again, and as you have seen, it is kind of slow, and this is completely normal because SceneKit uses hardware acceleration that cannot be simulated. So to have a better experience, you should use that with a real device, which we're, and this is also something that we're going to do later, because we also want to use motion control, which of course we can also only achieve with a physical device. But as you've just seen in the simulator, our camera does not follow our ball yet. And this is kind of problematic because we cannot control the ball if we don't really see it. So let's change that. And we need to do something called linear interpolation to smooth our camera movement, and we need to do that every time we render our scene. So therefore, we're going to access our scene views delegate. And we can do that by, first of all, go into our setup scene function, use our scene view, and set its delegate. So this is an SCN scene renderer delegate that allows us to actually manipulate some parts in the render loop. So I'm going to set this to self, and we also need to add this delegate now. And to add a little bit more structure to our game view controller class, I'm going to make an extension of this game view controller class at the bottom of our file, extending the game view controller, adopting the SCN scene renderer delegate, and adding some curly braces here, and then we can make some space for us. And then we still need to implement our delegate functions, which is update add time. And this function, this delegate function, is called every frame, so we can manipulate our camera movement very nicely here. So this is what we're going to do right now. And the first thing that we need for that is our ball's position. So let's use a ball here and use our ball node and its presentation. And this is a node representing the state of the node as it currently appears on screen. We're going to use that. And then we're also going to extract the ball position here, which we get by using the ball and its position. And then what we also need is a target position, which we actually want our camera to have. And therefore I'm creating yet another object. I'm going to call it target position. and position, and then I'm using a vector to actually define it. And we have an X component here, which is our ball position's X component. But what I actually want is that our camera has a Y distance of 5 to the ball and also a Z distance of 5. So I'm using my ball position again, using its Y component, also adding a Y here, and add just 5. And I'm doing the same thing for the Z component, using my ball position, its Z component, and add just 5 to it so that we have a nice target position. What we also need now is a camera position. This is a variable because we want to change that and use linear interpolation to actually dampen the camera movement a little bit so that it has a very smooth camera slide effect. So let's use a camera position here, camera position, and we're using as an initial value our selfie stick node and its position. All right, and now we will have a damping factor. Let's just define that right here. I'm calling it camera or cam damping. This should be a float value, and I'm going to set this to 0.3. And then, so that is a little more clear what we do, I'd like to divide all the 3 components. So I'm adding a X component for our vector, and this is going to be the X component of the camera position that we want to create. So let's use or create that by using the initial camera position and its X component, and multiply it with 1 minus the camera damping. And then we add the target position and its X component, and also multiply that with the camera damping or the cam damping value. And we need to do that now for all the components. So we have a Y component and we have a Z component. We can just copy that right here and also create a Z component and copy that again, and then we just have to change the Y value and the Z value right here. So this is a very cool technique so that we have this nice camera movement, very smooth camera movement, and then we can use our camera position and create a new SCN vector and initialize that with an X component using the X component, Y component, Y component, Y component, and a Z component. So with that, we have a nice camera position that we can now apply to our selfie stick node and its position, and it's assign our camera position quickly. Build that to see that we didn't make any mistakes. And since we are now controlling the camera, we should also scroll up again to our setup scene and actually comment out the allows camera control. And with that done, we can now run our game in the simulator and see if we can indeed follow our ball around. So here we are. I press on the ball and we're following it with a nice and smooth movement. Isn't that cool? So very great movement for our camera here. And then we can now continue on adding some movement using motion control. And since this is also something that should affect every frame of our game, we're scrolling down to our game view controller extension in the renderer did update at time function and add a little bit of more code at the bottom of this function. And here we're now using our motion helper motion and simply access the get accelerometer data function. And this is going to return for us a nice X, Y, X, Y, and Z component that we can use. And I'm now going to use self and my motion force property that we've already created to build a new vector with our 3 components. So the first one is the X value we get from the accelerometer, and we multiply that with just a fraction of the, to get just a fraction of the actual X value that we receive here, just to slow things a little bit down. So just 0.05 For the Y component, we add 0 because we do not want to move our ball in Y direction. And for the Z component, I'm going to take the Y value at 0.8 and also get just a fraction, which is the negative 0.5 here, just to move it in the right direction when we move our device to the front, for example. And then let's just add some white spaces here so that it looks a little nicer. And with that, we have the motion data and can now, outside of our closure, apply that to our ball node and use its physics body and just change its velocity and add our motion force. And this is why I have created the vector operations helper so that we can just add one vector to the other. Just a little bit of simplification here. And the last piece of functionality that we still need to add is collision detection between our ball and the trees. And therefore, we're going to have a look at our table again, because if you remember, our tree had a category bit mask of 2, so we activated the second bit. And if we're moving to the contact bit mask table, you can see that we actually just need to set the ball's contact test bit mask to 2 so that we get notified about a contact between our ball and the tree. And this is something that we can also do in code. So when we're opening up our game view controller and scroll to the top, what we can also do is just define a category, and we could set this to, or call this tree category or category tree, and then we can just set this to 1. And this is also something that we need to set up our ball node with. We can do that in the setup nodes function. And here we just take our ball node, take its physics body, and change the contact test bit mask and set it to category tree. And you could use a pipe and another category here if you wanted to, or if you wanted your ball to collide with multiple objects, but you have to define the category first, of course. And what we also need to do now, since we want to deal with collisions, we need to make a little adjustment in our setup scene function. Here we need to use our scene view, or actually just our scene, and access its physics world and its contact delegate property and set this to self. And then, just as we did with the scene view and its delegate, we're now also going to add an extension for our game view controller to actually adopt the contact delegate. So here right at the bottom of our file, I'm again creating an extension of our game view controller and adopting the SCN physics contact delegate protocol. And inside this protocol, we're going to add one delegate function, which is did begin contact. And this function notifies us now every time a contact is established. And I'm going to create a contact node variable here, which is going to be an SCN node. And I can now figure out if my ball is contact node or another node is the contact node. This is sometimes important if you need to distinguish between different targets, for example. So I'm now checking if my contact and its node A and its name is equal to ball. Then I can do or take my contact node and set this to contact B, to contact node B, because I want actually to identify the tree, and if contact and its node A is actually the ball, then B must be not the ball. So in our case, this would be the tree. And then I also have to check the else case. So I use my contact node again and set this to contact node, to contact and node A in this case. So this is a simple way to distinguish which of the two nodes that were part of our contact is actually the one that we're looking for, because in this SCN physics contact property, we get node A and node B, but we have no idea which node A and node B actually is. And what we can now also do is we can check if the contact node and its physics body and its category bit mask is equal to category tree, which is also cool, because if it is a tree, we could also check for something else here. Then we can play our sound, we can remove it, and also show it again after a period of time, so that we have kind of an endless game. So first of all, let's hide our tree when we made contact. So I'm using my contact node. This is the tree now. I set is hidden to true. Now it is hidden. Then I can also play my sound. I now want to play my saw sound. So I'm using my sounds dictionary and access the saw key. And then I want to run the play sound action or play audio. I use my ball node, run an action, which is an SCN action. I want to play audio. I want to play my saw sound, and I do not want to wait for completion. So this was the first part. Now what I'd also like to do is to show my tree again after 15 seconds. So this is a two-part action, an action sequence. So I'm defining my two actions that I actually want. So my wait action, this is an SCN action. I just want to wait for a duration, let's say 15 seconds. And then I want to unhide my ball, so unhide action, so SCN action. I create a run block here that gives me a simple node that I can work with, and then I can use this node and just set is hidden to false. And now these two actions can be packed into an action sequence. So I'm creating an action sequence here, action sequence, and this is going to be SCN action sequence, and then we have to supply it with an array. The first element is the wait action, the second one is the unhide action. And then I can actually run all of that stuff using my contact node, run my action, and pass along my action sequence. And now I'm going to test this on a real device. And I'm now running this game on my iPhone and using an app called Reflector to actually mirror my display on my Mac. So now once we're loaded, we hear some music, and I can indeed roll with my device, moving it around, so this works great. I can collide with one of those trees and they are destroyed, and I can also tap on my ball. We are actually following our ball, so this works really great. So this is actually all the game mechanic. You can see the ball reappeared now after 15 seconds, the other one as well. So we are actually done. Now, if this doesn't work for you at the moment and you do not collide with your tree, for example, and there is no collision, sometimes there is a little problem with that. So I've just opened up the tree again, and then you need to change the shape of your physics body to box or anything else, and then back to the default shape so that the physics body is built correctly. So that being said, what we can also do is quickly build another few trees for us. So I could just select one of those trees, hold my option key, and just move it around a little bit to copy it. And as you can see, another problem that you sometimes have here in the editor is that there is an offset between the real object and the physics body. And this is an error in the Xcode editor here, and you can't really do anything about it. But as you can see, you can quickly build a more complicated level. You can add a lot of more logic to it if you like. You can add a counter. You can do whatever you want with this template now. I hope you're creative. I hope you enjoyed this tutorial. And I thank you so much for watching, and I'll see you in the next one.